Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before I proceed, I'd like to request our members to kindly go to YouTube and search Ernest Sciences and Mathematics TV channel. Subscribe and engage us in the comment section, and also ring that notification bell so that you can be getting various updates on a similar discussion. So in this particular discussion, we're going to do the concept of differentiation of trigonometric functions. And of course, in our previous videos, we had looked at the concept of differentiation. And of course, I'm going to mention a few of the concepts that we had learned and how we can, of course, use them in this specific discussion to assist us find the differentiation or the derivatives of various trigonometric functions. Now, in this discussion, we're going to discuss on the concept of a theorem. And this basically is the theorem on the derivative of the function of the sine. Now, mentioned that we have different theorems for various trigonometric ratios together with their inverses. Now, in this case, I'm going to look at the derivative over the sine, therefore, which I'm going to give in differential form as d over dx, the sine over x in this particular case is equivalent to the cosine of x. So my activity therefore is to confirm whether basically this specific theorem is true. And of course, I'm going to use various discussions that we have had, or borrow from some of the discussions we have previously had on some of the concepts of trigonometry in order to find this. So therefore, from our last discussion on the concept of differentiation, I said that there are specific terms that we normally come across. And for us to conclude that a function is differentiable, then therefore there are specific conditions that we have, of course, to abide by in order to ensure that that specific function is differentiable and the limits exist, and therefore we can find a derived function from the original function. And I said that if we have a function y represented as the function f of x, we can find the derivative of that specific function, or represent the derivative of that specific function using the notation of f prime over x, which is given as f into x plus h minus f of x, where h represents a small increment in x, so therefore that is going to be given as such. And this, of course, is the limit as h tends to 0 in that specific order. So we're going to have this particular representation in an equation form, which basically depicts the aspect of our derivative. So therefore, we said that for us to describe this specific aspect of our derivative, I've mentioned that basically this specific section is referred to as a difference quotient. And of course, this other one for f prime refers to the first derivative, as I said. Therefore, for us to determine whether a derivative exists or not, we're going to use this difference quotient in determining that a specific existence of a derivative. Now, therefore, if this specific derivative exists, we're going to have this particular function over f of x referred to as a differentiable function at x. And of course, we're going to have this specific derivative f of x referred to, or f referred to as a derived function of this particular original function f, as I've said. Now later we're going to see that the domain, of course, of this specific two functions for the derived and the original function are going to be the same, and therefore we can represent this specific set of numbers for the domain for all values of x, which are the domain of the original function. Of course, they're going to also be the domains of that specific derived function. Now, therefore, having said about that specific summary, we're going to look at the concept of finding the derivative of the sine. And therefore, it's incumbent upon us to, of course, prove that basically the theorem that I've written on the board is true. Now, using this specific analogy, then therefore we're going to have the d over dx of this function, which is the sine over x, given as. So therefore, we're going to write it in that specific format. Our function is the sine over x plus h, given in that specific order. and then this is going to be minus the sine over x given as such. So this is going to be all over h, which is our small increment that I mentioned. So basically this is going to translate to another version of this function, whereby we're going to have 1 over h as a common factor, and then we are going to have the sine over this specific function x. Now, in our study about the difference and the sum of trigonometric ratios like the sine, the cosine, for this, the sum of angles, we have this specific, of course, notation that we are going to have, whereby we're going to have the sine of x plus h is equivalent to the sine x, the cosine over h, and then the sum over the cosine over x sine over h given as such. So basically this is a rule which states that if you have two angles which constitute over this specific angle and the phase difference over h, therefore we are going to have this specific first portion or the first portion of this specific section for the sine x plus h minus s sine x. The first one is going to be given in terms of the sine x cos h plus the cos of x sine h given as such, and then therefore this is going to be given as this one minus, so I'm going to do away with this for us to have enough space, and then minus the sine over x given as such. So the whole of this is going to give us that specific sum, and this is going to be represented in terms of the cosine over x, and then we're going to have the sine h over h, and then that one minus the sine over x, and then this one minus the cosine of h over h. So basically this is a simplification of this specific section of this equation, whereby we are going to have this first portion divided by h plus cos x sine h divided by h, and then this specific the whole of this is going to reduce into a form of a cos x sine h over h minus the sine x cos x over h, and basically I can be able to do this. So let me just reduce this space so that we can be able to do that one in form of so this is d over dx, the sine over x. So this our theorem is equivalent to the cosine of x given as such. So I'm going to take this specific space in order for us to basically confirm that the lower section that I've given is true. So we're going to have this one translated into the sine over x, and then this is a cosine over h, or a cos h over h, plus the cos x, the sine h over h, and then this one minus the sine x over h. So basically I've taken the whole of this one, this factor, and multiplied by these three specific section for the first one, the second, and this negative sign. So therefore we are going to do an arrangement in this case and try to put the terms, the similar terms together. We're going to have the cosine of x, the sine over h over h, this is the whole of it over h, and then we're going to have the plus the sine over x cos h minus the sine over x all over h. So if we try to look at the second section, of course, it's going to show us the sine over x over h, sine over x over h. We can factor or put those ones into the similar, or put them into brackets as the similar factor. So we're going to have this one, the sine of h all over h, and then plus, so that we have a common factor here of the sine over x over h into the cosine. So this space is going to be reduced, so I'm going to have this one. So we're going to have this one given us the cosine of x, the sine over h all over h, plus, so we have a same factor here for the sine over h, the sine over x all over h into the cosine h minus 1, basically given as such. So this one has taken the common factor for the two functions out, whereby we're going to have that one given as such. So in this case, therefore, this is going to reduce into this particular form. You can see the first section that we have for the cosine of x sine h over h is this specific function. And of course, the other one can be given in terms of minus. So this one can be changed to minus as the sine x over h. And then we're going to have this one given in terms of a positive. So in a sense, we are going to have this one given in this specific format, whereby we're going to have the cosine over x, the sine of h all over h, and then minus, we're going to have this specific section whereby we're going to have the sine over x over h, and then this one into the cosine h plus 1 given as such. So in this specific case, then therefore we can have this one, the whole of this still given in terms of so basically we're going to have this h represented as the common denominator over h given as such. Then we can as well translate this one into so this is going to be minus so there's a mistake here, we just try to rectify it. Basically, from this specific section, if we have a negative sign here, basically it's going to translate into a positive 1 and a negative the cosine over h given as such. And in this specific case, then therefore we're going to look at this specific. We said that we're going to give a general function where this specific increment in x tends to 0. Therefore, in this particular case, then therefore for the cosine over x, sine over h over 1, as h tends to 0, this specific function for the first section is going to reduce into the cosine over. Therefore, we're going to as h tends to 0, for this specific section of the function for the derivative, as h tends to 0, we're going to have this one given as the cosine over x dot 1, whereby this is going to imply 1, and then we're going to have minus at the second section, which is the sine over x, this one. So in this case, as h tends to 0, this second function for the cosine over 0 is going to represent 1. So therefore 1 minus 1 is equivalent to 0, implying that we're going to multiply the sine with this specific number for 0. Then therefore this second section of the equation is going to reduce to 0, implying that we are going to remain with the cosine over x times 1, which basically is equivalent to d over dx, the sine over x given as such. So therefore from our theorem, d over dx over the sine of x is equivalent to x, using this specific procedure that I've done on the board. So that's how we're going to handle similar, of course, elaborations on these specific discussions. And in our subsequent videos, we're just going to mention this. In case we need to remember this, I'm going to put a link over this specific video in our various description boxes of similar videos, so that it's going to assist us understand the same. So that is it for now, guys. Bye, God bless you. Catch us in our next video.